Lesson 1-1. Solve linear systems of equations and inequalities by graphing. A system of equations is more than one equation that has the same solution. Usually they're more than one variable. And in order to solve them, you need as many equations as there are variables. So if you look here at this example system, notice there are two variables. There are x and y. So I have two variables. I need two equations in order to solve it. By the way, this is written in standard form. We have the x's lined up, pluses and minuses lined up, the y's lined up, the equal signs lined up, and these are the constants because they have no variables. All right, so since a system of equations share solutions, a solution is an ordered pair that works with both equations. This is if we're talking two dimensions, x and y. If the ordered pair works with both equations, then both graphs have to go through the same point, because in your graph, when you go over x and up y, and if they both have that same point, the graph will go through that point. So the solutions would be where the graphs cross. So to solve by graphing, you're going to graph both equations on the same graph and then look to see where they intersect. All right, so let's try an example. Let's solve these by graphing. Well, if we take our first equation here, most of you will like it best if we solve it for y. So let's go through the process of solving it for y. So we're in slope-intercept form. Divide by the 2. So it'll be negative 3 over 2x minus 4 over 2. So I start at negative 2, and my slope is down 3 over 2. Or I could go up 3 over 2, like that. All right. Let's take the other one and solve it for y. So subtract the x, divide by 3. So it looks like I have negative 1/3 x plus 1 over 3. So I'm starting at 1/3, so about there, going down 1 over 3. Or I could go up 1 over 3, like that. So there's our two equations graphed. And so our solution is right there. So what point is that? That point is negative 2, 1. Let's try another. Okay, let's take this first one maybe and solve it for y, because that's typically what students like to do. You could find the x and y intercepts if you wanted. So it looks like it's 3 over 2x minus 10 over 2. So I'm starting at negative 5. I'm going up 3 over 2. There we go. Take the second one and do the same thing. Subtract the 3x. Divide by the negative 2. So it looks like it's 3 over 2x minus 1. So we start at negative 1, go up 3 and over 2. Or down 3 and backwards 2. And what do you notice? Well, they don't appear to intersect. Notice the slopes are the same. If the slopes are the same, that means they are parallel. If they're parallel, they don't intersect, and there is no solution. To solve a system of inequalities, you're going to do the same thing, graph them all in one graph, but remember with inequalities we have to do shading. So the solution is where the graphs overlap, so maybe you'll have one that's like this and one that's like that. Well, the answer will be where they overlap, or the shadings all overlap. See better when we do an example. So let's solve the system of inequalities. Let's start with the first one. X is greater than 2. This is a vertical line at x equals 2. It has the equal to, so that means it's solid because it's equal to. And then it's greater than, so that means we want the places where x's are bigger than 2, which means we're shading to the right. If I take this other one and solve it for y, so I'll subtract x of y is less than negative x plus 3. I'm going to start at 3, go down 1 over 1. It's not equal to, so it's dotted. And then it's y is less than, so we're going to shade below. Remember, if you solve for y, and then less than would be below, greater than would be above, so it's below. So our solution is where they overlap. So the solution is all of these points there, only where the two graphs overlap. All right, let's try one more. Conveniently, these are already solved for y. So the first one, we're starting at negative 4. I'm going down, wait, that doesn't fit on my graph, so we'll go up 4 and backwards 5. And it is dotted because it's not equal to. And its y is less than, so we're going to shade below because it was a less than. The other one, we're going to start at 2, go down 4 over 5, or maybe I could go up 4 and backwards 5. It's dotted because it's not equal to. And we're going to shade above because it's greater than, y is greater than. Remember, that only works though if it's y, if it's solved for y. So there we go. So where does it overlap? It does not overlap. Therefore, it is no solution.